Hey folks, it's Jim. Today we're going to go over Watt's Law. It seems on YouTube, Amazon, wherever. I seem to get a lot of questions that could have been answered by knowing Watt's Law. So today we're going to go over Watt's Law. And I think if you don't know it, today you should have a good idea. When I was taking DC theory, they told us to put it on a paper plate, tack it to our bench when we started. And that way in a couple of days we'd have Watt's Law down. Later on you'll get into Ohm's Law, and this is your Ohm's Law power wheel. Obviously a little more complex, but basically you can see those same values in there. And that's why I'm showing you the engineering values, I, E, and P, because that's what we work with when people are drawing circuits and things of that nature. That's what it's going to be. You may have looked at a schematic somewhere and seen I, not A, and E, not V, and kind of got confused, possibly some of you. So anyway, that's what this video is about today, Watt's Law. What is Watt's Law? Watt's Law is the relationship between the three values. Okay? P watts, I amps, E volts. What is their relationship? Well, anytime I want to find something, okay, let's say I want to find power. I have, down here we have a 250 amp hour big AGM tank, right? And I'm using that to run a small circuit right now. Okay, so how many watts are in that circuit, or in that battery? Okay, I have 12 volts, right? We know volts. We know amps, 250, right? So 12 times 250 gives us what? 3,000, that's right. Okay, so since I have two of those, if I wanted to run them in parallel and keep them at 12 volts, we would have 500 amp hours. So if I wanted to know how many watts total, what would it be? 500 times 12 is 6,000, isn't it? So now we could run a little more, maybe 1,500 watts. We could deplete those batteries overnight, right? So this gives you an idea of why Watt's Law is important. It will tell you what the potential of your batteries are. So down here on my other side we have a little 35 amp hour AGM. Well, 12 times 35 is 370, right? So that tells you the watt potential of that. Now why would I say, why do we want to know P or watts? Because more and more circuits are being shown in, or potential is being, or draw is being shown in watts, like LEDs, right? If you want to run, say, 6 10-watt LED lights, that's 60 watts, right? So you know watts, okay? You've got 60 total is what you're going to want to run. Okay, now is your circuit 12 volts? Okay, 12 into 60 goes how many times? 5. That means you're going to be drawing 5 amps. That means now you need at least a 5 amp fuse to run that circuit, right? So do you see where Watt's Law comes into play? It helps us determine our circuit values. It helps us determine our potential, our max draw, all of that stuff, okay? So let's go on up here to, this is my little circuit box up here. Many of you have seen this before. Okay, so let's go take a look at what we've got here. Okay, here we have a 10 amp charge controller. Since I'm only running lights and a Gable fan in the garage, okay, I only need a 10 amp charge controller because the Gable fan is 30 watts. The 3 10-watt LED light circuits, or lights, are a total of 30 watts. That gives me a total of 60 watts. So 60 watts divided by 12 volts is 5 amps. Since my charge controller is rated for 10 amps in and on the load side 10 amps out, I can run that whole circuit off the load side of my charge controller, can't I? Since it's rated for 10 amps, we came in at 5 amps, boom, we're good. Now, let's go up here. This is our fuse bus, okay? Down here we have our 12 gang positive bus, right? And up here we have our 12 gang negative bus, up there, okay? So over here, if you notice, I have a 5 amp fuse. You probably can't see it because we're kind of far away. And that protects my lighting circuit and my fan circuit if I wanted to run them both together. You may want to run a 2 amp fuse or a 4 amp fuse, but 5 amps, since I'm running a 60 watts here, I only need the 5 amp fuse because that covers me. 5 times 12 equals 60, right? Okay, so those are the things you want to know. Also, I just wanted to share, run an extra voltmeter. Anytime you're running charge controllers, things fail, things can get out of calibration. You want to make sure that your voltages are matching because you don't want to damage your batteries and draw them down. And that's why we want to know watts. We want to know the maximum drawdown potential of our circuit in watts so that we know how long we can run our lights and say our Gable fan like I do with this little circuit we're running here today. This thing out in the field I run can be charging 4 different computers, cell phones, or I can be charging a ham radio station, several of them, or I can be doing things. There's multiple uses for this. That's why I build a box like this, and that's why I get into this circuit stuff, and that's why we're learning Watt's Law today, okay? So I hope you can understand that, okay? So if we know that our total watt draw is 60 by 5 LED lights, right? Or 6 LED lights at 10 watts each is 60 watts divided by 12 equals 5 amps. So I need to fuse my circuit, get the proper wire size for the circuit, and that's what Watt's Law does. It helps us find our values, and hence we can now determine wire size, fuse size, charge controller size, and inverter size. Now let's go on the other side, and where a lot of people seem to have a problem. Okay, we just went through a DC idea there where we were up to 5 amps. Okay, now let's do the same 60 watts on the other side of our inverter. Say we're going to power an inverter. We've got let's say a 600 watt inverter, okay? And it's pure sine wave at 120. That's its output. Now on the other side of the inverter, say I'm running AC stuff, right? But it's still a total of 60 watts. Well, let's look at it now. How does that affect us? Well, if I'm now at 120 volts, right, and I have 60 watts, 120 goes into 60 what? 0.5 times, or a half an amp, or I, right? So we have half an amp now on the AC side, but you can see where people get in trouble. You're running a half an amp on the other side of the inverter, but on the DC side of the inverter, you're running 5 amps, 10 times more. And this is where it can people get in trouble sometimes. Think of that. If you're running 120 watts on a 120 volt circuit, that's 1 amp. Huh. But if you're running 120 watts on a 12 volt circuit, that's 10 amps. So you see what I'm talking about? Some people are making big mistakes in that area. You have a power factor of 10 to 1. From 120 to 12 volts is 10, okay? So you got to think that through, and that means your wire size needs to be much bigger. Your fuses obviously need to be much bigger. All that stuff on your DC side. And so that's why I'm showing Watt's Law today. I think it's very important. It would solve a lot of problems. It helps you determine what size charge controller you're going to need, what size inverter you're going to need, what size batteries you're going to need, what size wires you're going to need, and what size fuses you're going to need for a circuit. Knowing Watt's Law will help you determine all this stuff before you even begin shopping for your equipment. You can actually kind of design out a circuit. Always check with somebody who really knows what they're doing to make sure you've done things right. 2 heads are always better than one. Seek out a master electrician or somebody who really knows what they're doing before you even attempt any of this stuff. That's always my disclaimer. But Watt's Law will help you determine the actual equipment you need so people don't try and sell you a bunch of junk you don't need. Also, that's a big thing. Countless people have been sold stuff they just absolutely didn't need or were ever going to use. And on the other side, people have been sold stuff that was too small when their eventual goal was that they were going to expand. They would have been better off buying a higher quality, larger system to start with, or a larger charge controller, for instance. And then as they progressed up in inverter size, that charge controller would be able to go with the inverter. So that's why, again, knowing Watt's Law, what are your future goals, also can help you determine, okay, maybe I do want to buy this bigger charge controller up front, and I want to buy more batteries as I go along, okay? So all of this stuff is very important. Remember, you never want to burn more than 20% of your battery ever. You just don't. So You know, if I've got those 6,000 watts in those two tanks, I don't want to drop them down below 5,000 watts because you're going to shorten the life of your batteries when you do that. So when you're calculating battery size, that's where Watt's Law comes in too. How much do you want to use versus how much battery potential do you need? Okay, so anyway, I hope that this has been fairly explanatory about why Watt's Law is so important to the beginning of any solar journey. Really need to know these things. It's going to help you determine all of those factors: inverters, charge controllers, wire size, fuse size, DC breaker size, all of that stuff. Okay, and batteries capacity. All of this can be determined with Watt's Law. Anyway, I hope you're all having a happy holiday season. I know I am, and experience strength and hope. We're having a wonderful holiday season out here in Maine. It is warm, warm, warm. It is awesome. The ground isn't even frozen. So it's incredible. I can't believe it. But apparently we're going to get back in the below 20s into the teens again here in a short bit. So anyway, enjoy your holidays. Happy holidays. Experience strength and hope. Jim out. I hope this has been helpful. Again, Watt's Law. The relationship between these three values will save you a lot of headaches. Jim out.